our next speaker is from our sponsor, Filuta AI, and we're talking about effortless game testing with planning agents. So please welcome to the stage, Filip Dvorak.
And I will talk about QA. We have heard those stories where people had to, for 2 years, wake up every morning and drive motorcycle for 6 hours and validate that it's doing what it's supposed to. There are testers that through the day have to do 4,000 tests, try to throw the grenade, try to shoot the gun, try to use the horse, try to swing the sword. Those are uses or those are testing challenges that we have been seeing in the industry. And those are jobs that are not really fun, that people do not enjoy. What is the challenge with QA? And that's what I'm going to be talking about today. We have, compared to 2 decades ago, there has been a fundamental shift in the complexity of games. We have started connecting together so many different minigames. When we think about, let's say, starting with RPG system, on top of that we add monetization system, we add crafting system, we add dialogue system, we add quest system. All those systems that are added together create combinatorial explosion. And the number of different test cases that we can create on top of that and that we need to validate is so large that people cannot cover it anymore compared to 20, 30 years ago. This has been a challenge in the industry. Quality of the games is making or breaking if you succeed as a studio quite often. There are examples where if you have produced a game that had a quality such that it wasn't playable, you had to take it down from PlayStation Store, from Xbox Store. It's critical to be able to create high quality games, and you cannot so easily use in early access your players as game testers because they became spoiled. They do not like to play games that are broken anymore. It was possible to do it 10 years ago. These days, not so easy. So the complexity of games is growing exponentially. The games are developed extremely dynamically. The code changes all the time. What can we do about it? We have started using autonomous systems from space exploration to automatically test the games without any instructions. You only give our agents the goal, the test goal it should achieve. It can be anything from finishing the game, such as destroy the enemy base, save the princess, kill the dragon, whatever your game is. And the agent is going to figure out and find the path how to achieve it. Or fail doing so, in which case you have identified a bug. When we look at automation solutions, such as test scripts, that are often industry standard, they can be expressed as a metrics. When we look at average length of a test case and how many lines of codes and steps we need to make, that would be our rows in the table. And at the end, we have the goal we want to achieve. If we have M of those tests, then we are looking at metrics M by N. Each of those individual cells represents a line of code. In the gaming industry, the current minimal cost for creation of one line of test code is about $10 in your game. This is an average that we were able to get from the industry, from the available data. The minimal cost for maintaining this one line of code is $3 per year. Those costs add up quite a lot. What we can do, we can provide testing solution where you do not need to maintain the steps. You don't need to maintain the lines of code. You only maintain the goals. And our agents are going to dynamically create the steps necessary to achieve the goal. This is a fundamental contribution. Also, compared to people on average with customers that are working with us for more than 14 months, we are getting to about 17.5 larger value of testing that you get per $1 that you spend. So let's say instead of 1 hour of testing by human testers, you get 17.5 hours of our agents testing. Also, Everything is data mined. We are providing complete overviews of what the agents are doing. You can test the game dynamics and the changes in gameplay. When, for example, over the time, you see how long different levels take to play through, how different functionalities are changing. If you make a small change in the game and it has collateral influence on 20 different tests, you will identify it. You will right away see what is the impact on the playability. We easily integrate into any type of Jira, bug tracking, Azure development environment. And the reporting that we can provide is also pretty open to any of your ideas. We are providing out of the bat large number of statistics and anomaly detections, so you see how your game is changing in time. But let's talk about who we are. We have started as space engineers, essentially. It has been 16 years of my life. The space applications are fun, but I may potentially have some code that will fly on a mission to Titan. I'm probably not going to live to see the results of it, because it takes 9.8 years to get there, then find the right window to get back. And if I expect my age to hit 80, I may see the results, but not necessarily. So we have taken the autonomous technology and we have found a vertical on the Earth where it can bring value. We think in gaming QA, this is significant value. People spend each year, for last year, the estimate is that $17 billion has been spent on QA. We can help there and make it cheaper and more efficient and make the games better. The team, we have 14 PhDs, 3 professors, gaming professors, Stanford professors. We have industry leaders in AI architecture from AAA studios, from Activision, from CDPR, from Kingdom Come, and engineers from Microsoft and Google. So this is our company that with which we are trying to help the industry with QA. I will have a small scientific intermezzo. These days, terms that have established itself in separation of different concepts of AI are symbolic and subsymbolic. Subsymbolic are all the neural networks, language models, all those statistical models that kind of merge causality and correlation, that work with big data, that are good at analyzing and transforming between different form of frameworks, and that are also based to ChatGPT and other systems. On the other hand, symbolic AI are those explainable, auditable decision-making systems that I have historically deployed, for example, in oil and gas operations, where automating drilling and being able to validate every decision that happens in the process, and every decision is critical decision, because if you do something wrong, it kills hundreds of people and destroys the nature. In those processes, we cannot deploy subsymbolic AI. We have to use symbolic models that are efficient, auditable, and readable. And our technology is based on symbolic models, which are supplemented by subsymbolic, primarily language models that allow us to migrate, explain, and process the large data better. This combination is historically called neurosymbolic becoming composite horizontal multimodal AI. The advantage of symbolic AI is that it scales exponentially better than reinforcement learning. Essentially, as a technology, we are able to learn within your game world how to autonomously play through thousands of actions, hours of gameplay. You cannot do that with reinforcement learning. You cannot do it with statistical model. That's one of the largest advantages of symbolic AI. That's why it's the stack that is deployed on Mars rover Perseverance, and it's running it, I believe, from February 2023. The autonomous AI planning stack is operating the rover. This is what we know as state-of-the-art in autonomous control as a human civilization. Yep, and that's the rover. And the planning agent loop that we are using can be described in a very straightforward fashion. We are actually solving the combinatorial problem of finding the best sequence of transitions in the world to achieve the goal. If we fail doing so, we find another. This is a way how the agent is constantly adapting. It is constantly observing the world, and it is finding the next optimal sequence how to achieve the goal, potentially removing the sequence it has been executing, doing different sequence that was found to be better. And this allows our agents to act as game testers. Also, they can act as game breakers. You can tell it, let's say you have a fairy tale game. You can at the same time have an agent that is testing that you can save the princess, and you can have an agent that is testing that you can kill the princess. And based on the type of your game, what we are doing in the game, the interpretation is up to you. One of that is supposed to fail, one of that is supposed to succeed. For those of you that are familiar with planning, the planning technology has been used in games for some time. It's usually known as GOAP, goal-oriented action planning. We are using it in a different fashion. We have built combinatorial solvers, pools of solvers in the cloud, and we can put your whole game into the planning model. This has historically not been possible for characters in the game because you were constrained by some latency of your characters, usually had to respond within 100 milliseconds, and the agents had small models. We can do complete models of your whole game. We can put questing system, dialogue system, everything can be tested and can be in our model, tested by our agents. We usually like to start with the regression, functional, and smoke tests. Those tests that are boring for everyone, and they need to be done. And if you do not want to maintain them, we can take over, and we can keep testing it for your game, for its whole development, without any updates. Golden paths and side paths are natural extension. And we are also able to help with identification of bugs that do not necessarily break the functionality, but they represent fundamental unexpected change of the gameplay. It is something that you can identify with statistics with watchers on your gameplay characterization. Even before you had a single human player, our agents can populate your game. They can create a data set of how the game is played, and you can polish and prepare the game before the release. And conceptually, we are not good for Angry Birds, not ideal for Flappy Birds. Those games do not have much causality or logic, but we are absolutely great for RPGs, puzzles, card games, adventures, real-time strategies. We are doing Dota type of games, Heroes of Might and Magic. We have a very broad scale. I would say about 80% of the market are a great fit where we can add significant value. We are fully integrated into Unity. How do we do it? We have Unity plugin. That plugin dumps your world state. You define the tests. You tell our engine, I want to test these logical conditions. If I can achieve it, if the agent can achieve it, and we will start running it for you based on the triggers that you ask for. We are supporting Unreal, and we can integrate into custom engines as well. And can I ask for the video, please?
Thanks to today's technologies, it's possible to develop a game on your own or with a small team. In my opinion, AI-driven QA is the way forward, purely given that normally to test a game you need hundreds of people. You can have human testers testing core parts of the game rather than focus on smoke tests repeatedly. Filuta AI helped tremendously with the QA process. Their planning agents tested a plethora of features, from core mechanics to edge cases, without manual scripts. Thanks to the automated system, its logging and video recording, I was able to detect problems quickly and effectively make a fix without diverting internal QA resources. Their team has been fantastic throughout the process, and Filuta AI has been a huge asset. Bohemia Incubator helped with marketing and releasing of the project, including funding throughout the process.
So that was one happy customer testimonial.
You didn't take the easy part.
And I have a few minutes for questions. You can always write to us. We are happy to start a pilot with you. And please feel free to contact me. Nicole from our team is going to prepare some giveaway bags that should be useful. And yes, do you have any questions?
That was great. Thank you very much. So yeah, do we have we have a question straight away. There we go. Yeah, we've got a couple of minutes for questions. So there's your mic.
Thank you very much. Kindly know that I'm not a tech expert. Okay, you raised the point with the engine. Would you please explain briefly what plays the engine into your technology? The game engine, I mean.
The engine-wise, we support Unity and Unreal, and that's a matter of already having the plugins that are able to feed the data from the engine into our agent and vice versa. If we come to custom engine, it doesn't mean that it's necessarily more complicated. Our agents, they basically, it's as if you imagine the rover on Mars. It needs to observe the world around it, and it needs to be able to perform actions, and it needs to be well defined how to do it. So if there is a scripting language, automation type of language, if there is already some interface for agentic applications in your engine, then we can just connect to it, and that makes it much easier.
Great. Thank you very much for your question. Thank you. Do we have any other questions from the audience? One more. Take that one question and then there. Oh.
Thank you for the presentation. Actually, my question is quite simple. Is it possible to run this agent locally or on premises, or it's only cloud-based thing?
We do have some deployments on-prem for especially customers in defense, because that's their requirement. It is slightly challenging to run it on-prem with consumer hardware, because the agents are essentially combinatorial solvers that are extremely resource hungry, and we are experts on how to operate them. We have scaled them in cloud. We can operate them in a cloud environment efficiently because we are pulling them together, the combinatorial searches. At this moment, we don't have easy offering on-prem.
Great, thank you. I think the time being what it is, we'll leave it there. A round of applause, please, for Filip.